Assalamu alaikum. Today we were talking about the chapter 4, which is talking about the trusses. First of all, what is the trusses? Trusses is the sum of members are joined together to form a structure. As we say here, we have a members. All these members are joined together by a joint, and we call this a truss. And we have two ways to solve problems about trusses: method of joints and method of section. Method of joint. This method for finding the forces in the members of a truss consists of satisfying the conditions of equilibrium for the forces acting on the connecting pin on each joint And number 2 is the method of section. This method of section has the basic advantage that the force in almost any desired member may be found directly from an analysis of a section which has cut that member. And basically we use the method of section, except if they ask me in the question, solve this problem about by the method of joint, or the method of section doesn't work with me. And now we have two types of force: tension force and compression force. Tension force, if the force pulling away from joint, this is the joint, and if the force pulling away from joint, we call this a tension. And if the force pushing to the joint, we call this a compression. And if we want to solve problems about trusses, first of all we draw a free body diagram, and then find reaction if you need it. Some of problems we didn't need the reaction. Number 3, we find the forces at the members that we want. Okay, let's take this example. Calculate the forces in member DC and DE. DC and DE. First of all, we draw a free body diagram. Here is DC and DE, and we assume these forces. Okay, first of all, this is by method of joint. First of all, joint DE, summation of y equals 0 minus 14. This force is go to the minus on the minus y axis, and minus DE, we analyze this force in the x axis and y axis. Minus DE cosine 33.7 equal to 0, and DE equal minus 14 over sine 33.7 equal minus 25.23 kilonewton. And if we get a minus, that's mean we assume this force in the wrong direction, and just we write it again without a minus, and we put a new direction of it. And now we find the joint DE, and now we need to find the joint DC. summation of x equals 0 minus dE cosine 33.7 minus DC minus dE cosine 33.7 minus DC equals 0. And we find this force before, it's 25.23 and minus positive 25.23 cosine 33.7 minus DC equals 0, and DC equal 20.99 kilonewton. And now we find the joint DC. And this example is about the method of joint. And now let's take the example about the method of sections. Here is the question: calculate the forces in a member AB and AF. AB here and AF. First of all, we cut here to find these forces, and we draw a free body diagram, and we assume these forces. And if we want to find the force AB, we take a moment and a force F, which is cancels these forces, and find this force AB. Summation of MF, moment here, MF equals 0. AB multiplied by 3, which is the distance between moment F and member AB, minus 14 multiplied by 6. 3 and 3 is 6, equal to 0, and AB equal 14 multiplied by 6 over 3 equal 28 kilonewton. And here we find the joint AB. And if we want to find the AF, we take the force, all the force on the y-axis, summation of y equal to 0. AF cosine, we analyze this force, this member, AF cosine 45 minus 14 equal 0, and AF equal 14 over cosine 45 equal 19.8 kilonewton. And we find the AB force, members AB and AF. And now we want to talk about the part 2 of chapter 4, which is talking about the frames and machines. A structure is called a frame or machine if at least one of its individual members is a multi-force member. Like here we have one members and two force, multi-force, 18 Newton, and the force is opposite of the force. And let's take an example about it. Here is find the force at B and reaction at pin A, and force B here, as we say here, force B and pin A. If we want to find the FB, we take a moment on A here. Okay, summation of M moment in A equal to 0. FB multiplied by 35 millimeter here, which is the distance between B, force B, and pin A, minus 18 multiplied by 95 millimeter and equal to 0. FB equal 18 multiplied by 95 over the 35 equal 217.14 Newton. And here we find the force B, force in B, and now we will find the reaction at pin A. Summation of x equal to 0. Ax, there is just Ax on the x-axis, equal to 0, and summation of y equals 0. Ay minus 18 minus 217.14 Newton, which is found it before, equal to 0, and Ay equal 18 plus 217.14 equal to 297.14 Newton. And here we find the reaction at pin A.